Welcome to the webinar on the ETP 2021 PhD programme. So before I go any further, I'd just like to invite the Chair of ETP, Professor Sir Jim MacDonald, to welcome you formally to this event. Thanks, Jim.
Thanks, Stephen, Mark, and good morning. Good morning, colleagues. It's great to have you attending this meeting this morning, but really by way of a briefing. And to get you interested and probably primed to respond to the opportunity. I'm not going to take up a lot of time. Some of you will be more aware of ETP than others. ETP is, a highly successful pool, part of the Scottish research landscape. It's been going for about 11 years. Myself and Professor Paul Mitchell, who's on the call as well, have been involved since its outset. Stephen Mark and the team are doing a terrific job keeping it going. But today we're talking about the doctorate programmes. ETP has really acted as part of the catalyst to support and bring together the energy research community in Scotland to good effect. Many of you will have participated in various programmes. First and foremost, it's about the collective strength of the Scottish research base so that we can compete all the more effectively, both nationally, in the UK as it were, and internationally, certainly. And many of our colleagues across our member universities in particular have done an appropriate leveraging of the ETP. The other big component that's been enormously successful has been our knowledge exchange network. Coming to the phase 3, we're planning for phase 4, hopefully with ongoing support from our colleagues in Scottish Government and its agencies, having connected to almost 1,000 companies, supporting them in the energy domain. But today is all about what is really our flagship programme, which is the PhDs, the industrial doctorates. I mean, already we've made 127 awards with fantastic support from our colleagues from Scottish Government, from whom you'll hear more shortly, giving us another 24. That'll be 151 PhD studentships, which has attracted almost £4 million of industrial support into it. And for those that bid on these things, that's approaching the equivalent of about 4 CDTs equivalent. So that's an enormous resource in terms of PhD capability. And I'd also like to take the opportunity to say a big thanks to our colleagues from Scottish Government, particularly the Energy and Climate Change Directorate, who have been absolute stalwarts in terms of supporting it, even when funding for research has been challenged, and it is, and we understand why that is. I think our colleagues from Scottish Government have stepped up to the mark and invested further in ETP to allow us to drive forward, most importantly, research and innovation, the production of great talent that acts as the spearhead, as it were, to drive forward energy technologies in pursuit of achieving net zero. And for all of you today, I would encourage you, once you've heard what the direction of travel is, to think about high quality proposals and engage as quickly as you can with Stephen, Mark and the team. And I look forward in due course to seeing the great proposals that will come forward. So Stephen, Mark, thank you very much. Back to you. Stephen, Mark, you've got a £20 fine, you're on mute.
Thank you very much. I can't unmute myself while I'm share screen. So apologies for that. So the presentation is being recorded and it'll be available for download later from the ETP website, and the actual PowerPoint itself will be available for download. I've got limited time. I don't want to spend too much of your time. You're here to listen to the Scottish Government, who are very welcome to be here. But there are a few things that I need to say about the presentation. Please, can you mute both your audio and your video? That would be appreciated. So questions will be answered in the last third via the chat function. So if you have any questions, please put them in the chat function in Teams. Right, most importantly, right, the first thing is 12 noon, Friday, 11th of June is the deadline for this call. Hopefully you will all know that by now. So that's approximately 2 months' time from now. Just to summarise what this is phase 3, the start of phase 3, 720k funding from the Scottish Government, for which we're very grateful for that. It will fund around 24 projects. There are 4 calls under this phase. but unlike previous times, there will be a call every 9 months. It's not yearly. You will notice that things are different. This time I've put in Burgundy. And so the Scottish Government's offer letter actually covers the entire programme, all 4 calls, not just year 1. And so there is actually a timetable. This is it. It's also in the application form, and you'll also see it on the ETP website. But the calls will be every 9 months. So the next call will open on the 30th of November this year, with the deadline 28th of February. The current call is very similar to the previous call. So hopefully you will know all about third funding model and so on. So same lines, 6 grants of up to 30K as usual. They are competitive. Okay, so there is a panel that will meet. It's open to all researchers across ETP partner institutions, all 13 of them. As you know, there is a co-supervisor and a partner ETP institution. It requires industrial sponsorship and engagement, and it is open to any student, any location. I put that because I often get that question. Okay, they can be in the UK, in Scotland, in the EU, outside of the EU. It doesn't matter. It's up to the university to decide what is the best student that fits their project the best, not for ETP. As for the application itself, the application form is available on the ETP website. Again, but this time, all applications need to be submitted through your institution board member. Okay, so that's different from previous years. We want the board members to get sight of all the projects before they actually get submitted to me. And the ETP board member of the host institution must submit a letter of support accompanying the application. Also, this is something that's slightly different. We want statements from both institutions of the supervisor and the co-supervisor that the supervisors meet their own regulations for PhD supervision. We were a little concerned last year about the level of supervision, so this is just to make sure that we get that those concerns allayed. As usual, letter of support from a co-supervisor, letter of support from an industrial sponsor, and a student CV if already identified. So the rest of it is not much change. The actual application form is not particularly different. Timeline for this year then, call open today, webinar today, last week's webinar today, deadline 12th of June. The panel review is on the 16th of June, chaired by Sir Jim. The board ratification is at the end of June, can't remember the date exactly. So we hope to get the offers out by mid-July, which means that you'll be able to get your students ready if needed by the beginning of the new term in September. But in any case, the student must be in place by the end of December this year. So you have essentially 6 months to engage with the student. So the invoice and the evidence of student registration must be received by us by the 31st of December 2021 so that we can reimburse you. Okay, supervision. Again, you know about supervision. Supervised academic from partner ETP institution, co-supervisor from with a letter of support from a partner ETP institution as well. Industrial sponsor also provide a letter of support and a supervisor. That's all the same. But as I mentioned before, we actually need evidence that the supervisor from the institutions fit with the host institution's level of supervision, and what we need for evidence of that is a letter from each of the institutions about the supervision. The students themselves, again, students can be any nationality. Okay, first or 2-1, or if they have a master's degree in appropriate discipline, that's also acceptable, and should be registered, as I said, with the host university by the 31st of December 2021, so the end of this year. I'll just highlight IP again. The IP hasn't changed, but again, we get questions about it all the time, so I just wanted to highlight this. ETP does not need any IP. It is not part of our contract with us. ETP is not a legal entity. We don't take any IP. The existing IP in the project remains the property of the host university, and the project IP itself is the property of and vest in the host university. So these are 2 statements in the contract. However, what the host university decides to do with that IP is really up to them. Okay, and I'm sure that the host university has a paragraph in place to cover IP with the industrial sponsor. But again, we don't take a view on that. That's really up to the host university to decide the best way to deal with the IP that's generated during the project. But again, to reiterate, there is this statement in the contract between ETP and the host institution, and it's to do with allowing Scottish Government access, not ownership of, but access to the IP generated during the project. Okay, so that is part of the contract, that statement. Okay, onto the assessment part. So the assessment is exactly the same as the previous 4 years, 4 criteria, each marked independently. So total of 30 marks, here they are. And then the marks aggregated. So if there are 6 people on the panel, that means that each project can get a maximum of 180 marks. And essentially the assessment is done by ranking the projects according to the total marks. Of course, there is a slight amount of give and take. There's lots of discussion at the panel to do with the relative quality of projects, but essentially the fundamental way that we mark is simply to add all the marks up of the assessors. Also, it should be noted that there is a representative from the Scottish Government who is on the assessment panel. So specifically going into the actual components, there's a project abstract which is not assessed, but which is very useful because it promotes your project. So it's essentially a 100-word elevator pitch, and it's used in promotional material. So we want to know about the challenge, we want to know about the actions, and most importantly, what are the impacts and benefits of your project. The second section, not assessed, but is a description of the project, okay, high-level description, and it enables the assessor to get some kind of context for the project, so it helps us to understand the rest of the proposal. Doesn't have to be very long, but you need to explain to somebody who is about what exactly the project is. Now, today is really about this section. So how your project aligns with the Scottish Government strategic aims, 5 marks. In the actual application, you will see that I will said that a specific area of interest will be communicated in due course. Well, that's today. Okay, this is where you find out exactly what those specific areas of interest are. So you need to demonstrate how your project aligns with one or more of these areas. Last year, we had at least 7 projects which made absolutely no reference to the 7 specific areas of interest that we had last year. So you need to do that to get your marks for that. The second part that is assessed, which is demand driven by industry, 10 marks. So this is based as well on the letter of support that you'll get, that we need from the industry partner, detailing the level of quality of support and the industry leverage. But also you must demonstrate how the demand is driven by the wider energy sector, not just the industry partner. Because if that's just as far as the project is going to have impact, then you're going to score less marks than if it has impact amongst the wider industry. So you need to demonstrate that. It has to have significant net KE potential between academia and the industry, and also potential for impact, jobs, turnover, wider society. Academic quality, 10 marks. So really I listed it here, but really specific overall aim of the project, the academic quality itself. Are the objectives clear and achievable? We often find that projects fall down on this specific point. You have to demonstrate exactly what the objectives are and how achievable they are, and evidence those. Quality of academic environment of the supervisors and the unit in which it's placed. The potential for academic impact, papers and such like, and also, most importantly to me, the benefits to the student, how they benefit from this actual project. So those essentially are what the academic quality is marked on. And finally, alignment with ETP strategic framework. So you need to go and have a look to see what our strategic framework is. What I mean by that is what its mission is. Remember, it's around collaboration and impact based on excellent research. So make reference to our strategic framework. You'll find it on the ETP website. But also, how are you going to engage the wider ETP community? It's not just about the 2 host institutions. It's about all 13 partner institutions. Remember, there are theme groups. How are you going to engage the theme groups within which this project would be located? And how are you going to engage with other ETP PhD students? So that's it from me. I wanted to keep it as short as possible, but as Jim mentioned at the beginning, talk to us. Okay, we want to nurture projects. It's absolutely fine to have speculative projects that come in on the date on the 11th of June, but we would like to know about them in advance so that we can together, hopefully we can foster projects which really meet our needs. So I will be open for questions at the end. So right now, we're going to move over to the Scottish Government, who will explain areas of specific interest. So Craig, it's over to you.
Thank you, Stephen. Mark, I am searching around for where to share my screen. Here we go. Share content. Okay. So yes, thank you. My name's Craig Frew. I'm the low carbon innovation team within the Director for Energy and Climate Change in the Scottish Government. I'm the primary point of contact between the Energy Technology Partnership and the Scottish Government, and we're very delighted to be able to support the ETP PhD studentship programme, as well as other activities of ETP, and we're very grateful for the dedication across the Scottish research community in terms of challenging us and taking our high-level policy ambitions and translating them into something that's of real tangible value to our policy agenda and to the economy of Scotland in terms of creating that kind of competitive advantage in the energy sector, which is one of our core drivers in the programme. So thank you for that, and thank you for the opportunity to speak today. I've brought some colleagues along with me today, and our intention is to provide some overview of our policy priorities across the following areas. I'll start by providing a brief overview of the challenge in respect of our heat and buildings strategy, and my colleague Neil will cover the large-scale renewables sector primarily. Juliet will speak to hydrogen. Stuart will come on to talk about industrial decarbonisation challenges, and then Simon will wrap us up with a rounded approach to the whole system and grid challenges. So I think what's important to highlight at this point is that these aren't exclusively the areas that we're looking for projects to come forward in the call this year, but these are our priority areas. So we're not explicitly ruling anything out through this presentation, but we are very much highlighting where our priorities lie. So in terms of our journey to net zero in the heat and buildings sector, back in February, my colleagues in the heat strategy unit within Scottish Government published their heat and buildings strategy, which set out an ambition that by 2045, all homes and buildings must have significantly reduced their energy demand, and almost all buildings must contain a net zero emission heating system. So it's a huge challenge in terms of deployment, but even more strikingly, I suppose, and urgent is the 2030 interim target set by Parliament through our statutory emissions reduction targets, which will require homes and buildings to have a 68% emissions reduction against 2020 levels by 2030. And that requires significant progress to be made in terms of improving the energy efficiency of buildings. And we've set a framework of standards and proposed regulation to see all homes and buildings reach EPC-C by a backstop date of 2035, and by 2030 we'll need to see significant progress against that target. The emissions intensity of the gas grid will need to significantly reduce, blending green gas to at least 20% volume. We'll need to see the vast majority of off-gas grid homes decarbonise and switch to zero emissions heating systems, as well as at least 1 million homes on the gas grid switching to zero emission alternatives as well. And we need to see significant progress in the 200,000 or so non-domestic buildings in Scotland, with a further 50,000 of those buildings switching to zero-emission alternatives. It's a growing market, therefore, not just in Scotland, but across the UK and Europe. To give you an indication of the size of the zero emissions heat market, in Scotland, we anticipate that by the late 2020s, we will be installing around 200,000 zero emission heating systems in existing homes every year. At UK level, by the mid 2030s, the UK government anticipates that that will reach over 1 million, with their target in the Prime Minister's 10-point plan of 600,000 heat pump installs by 2028 per year. And across Europe, the market is significant. By 2024, the European market is expected to grow to around 2.6 million zero-emission heating systems per year. So there's a huge market opportunity here. And in Scotland, domestically, we need to quickly ramp up the installation of low and zero emissions heating systems, and that will require action across several different approaches to do that. We've identified in the heat and building strategy energy efficiency, heat pumps in both on and off gas areas, and low and zero emissions heat networks as being strategic priorities in the near term over the next 10 years out to 2030. But we also recognise the role that technologies such as hydrogen and green gas may play in the longer term when these technologies develop through the 2030s, through the 2020s, but are unlikely to play a large part in reduced emissions before then. That's not to say that we are that we rest on our laurels when it comes to hydrogen for heat, but potentially an area that we would really like to see some positive research contributions come through on. So just quickly, in terms of the heat and buildings innovation challenges, we've pulled together this very high level narrative to explain where we see some of the technological innovation challenges in this sector. In terms of heat pumps, which we expect to be a key strategic technology, getting these into buildings, the modular pre-packaging approach that reduces installation time and supports the deployment of heat pumps is a key area, as well as a shift towards sustainable refrigerant gases, so a shift away from conventional F gases for heat pump refrigeration, and looking at the efficiency and temperature output of heat pumps as well. In terms of smart systems, we need to think about how technologies like heat pumps and the electrification of heat works at a system-wide level, how we maximise value streams for the technology through flexible demand management, how these systems integrate with other technologies such as PV at a building level, and how we use them as part of a whole system solution. In terms of energy efficiency, there remains a challenge with hard-to-treat buildings, particularly pre-1919 stone-built properties in Scotland. How do you reduce demand effectively across that portion of the building stock? How do we reduce the cost of demand reduction and energy efficiency measures through novel installation methods? And how do we move towards more sustainable materials, thinking about the embodied carbon within conventional energy efficiency materials? In terms of storage and distribution, low temperature distribution systems within homes, how do we make sure that technologies such as heat pumps and heat network connections are compatible with the conventional heat distribution systems at a building level? How do we use, can we develop novel approaches to instantaneous hot water within buildings? And how do we save space when it comes to thermal storage at a building level? In terms of heat networks, the heat interface unit is a key area for optimization and looking at direct heat interface unit systems for heat networks, thinking about trenchless technologies and radical routing for heat network infrastructure to reduce the civil costs, and also looking at shared civil approaches with other utilities. And I touched on hydrogen for heat before, but in terms of hydrogen for heat, there's still significant amount of innovation and technology development, particularly around the safety case for domestic appliances, thinking about the skills, maintenance and servicing requirements that come with hydrogen for heat, looking at area-based strategies, what areas of the country and what sectors would be most suitable for the large-scale deployment of hydrogen for heat. And we're still at an early stage of our thinking in terms of developing our thoughts on the cost and system benefits of hydrogen for heat. So a key value case to be made there for hydrogen for heat in an area that we can expect to see research come forward and support. So that's all I'll say about heat and buildings. I'll quickly hand on to my colleague Neil, who will be talking about large-scale renewables. Neil, are you there?
I am, Craig, thanks. And good morning, everyone. I'm Neil Rafferty. I'm the head of electricity networks and large-scale renewables, working in the same directorate as Craig. I'm going to try and be quite quick here because I think that my colleagues have got a greater range of emerging issues to cover in areas which are hugely important in energy policy and climate change terms, but we don't quite have the platform which renewable electricity in Scotland currently has, and where there's a significant understanding of some of the technological innovation challenges facing the sector. Just quickly by way of context, I mean, Scotland has been a beacon for renewables growth over the past 2 decades, which is driven by our natural resources, but also the supportive policies and targets and legislation of successive Scottish governments. Provisional figures which have just been published show how close we've come to meeting the target of generating enough renewable electricity in Scotland to meet 100% of demand, or the equivalent of 100% of demand in 2020. That figure is over 97% before we get final figures for demand in the year in question. So, progress has been tremendous. The climate change plan update, which we published at the end of last year, sets out very ambitious and binding targets for emission reductions, as Craig said, across Scottish economy and society. And what that makes clear is that we're going to need much more renewable capacity built and installed across the land and in our waters. And we expect ministers to continue, excuse me, to want to support research and development into wave and tidal power, because there's also going to be a need for negative emission technologies such as air capture and bioenergy with carbon capture and storage, which I'll say a little about in a moment. But the vast majority of the capacity that is going to be essential to meeting those targets over the next decade is going to continue to come from onshore and offshore wind development. Now, in onshore wind, there are a number of challenges which are quite well established in areas where research has been important, innovation has been important, and we think it's going to continue to be. On lighting, for example, we know that turbine sizes and tip heights continue to grow, which means that the requirement for aviation lighting becomes increasingly important. And there are several aspects in this area where additional research can play a part, such as into the distinction between perceived and actual visual impacts, innovations in design, which can reduce those impacts where they arise. On radar, and this is as much for offshore as onshore, because wind turbines are very large objects, with parts that move at very high speed, their effects on military and civil aviation radar systems need to be taken into account and mitigated as far as possible. And my team has been involved in looking at these issues and discussing them with the sector for many years at a Scotland and UK level. It's evident that some of the barriers to progress are systemic and political, but it's also an area where research and innovation can play a major part in reducing or eliminating the effects of turbines and radar systems and unlock potential for much more development in parts of the country where that is currently either impossible or economically unviable and severely limited. When it comes to noise, the debate about the effects of wind turbine noise and low frequency sound on local environment and potentially on health is something that's been around as long as I've been in energy policy. It's another area where further academic research could play a part in helping understand and address the physical and psychological factors that can be an issue here. Blade material recycling, it sometimes feels quite low profile, but it's hugely important. You consider especially that at the moment there are around 14,000 blades globally reaching the end of their usable life over the next year or two, which is about 50,000 tonnes of material at the moment heading for incineration or landfill. We know that there are organisations, and we work with some of them, who are really looking hard at this area and looking at some of the recycling technologies and innovation that can make a difference, as well as the use of more sustainable materials and blade designs, which have got end of life and disassembly challenges more in mind. But with Scotland's potential and targets in mind here, it feels like an area with obvious and important strategic value and potential. For offshore wind, there are similar challenges to onshore, such as radar mitigation, but the potential for research and innovation to drive further cost reductions is greater for offshore wind, especially when it comes to floating wind. This is an area where Scotland has got huge potential because of the nature of our waters and seabed. It's an area where we have led the way by supporting some of the first significant pilot and demonstration projects. Some of the cost reductions we're talking about are going to come from development at scale, which are going to depend on policy and market drivers. But there's obviously a role for more research and innovation in this space as well. Now, we've been funding a lot of research and demonstration over the past few years, including new approaches to seabed anchoring and mooring for floating turbines, heavy lifting operations, dynamic cabling, and we believe there's great scope for more industrial and academic research work in those areas. When it comes to system operability, there's a huge amount of overlap between the continued deployment of largely variable renewables and zero carbon generating capacity across Scotland and the energy systems into which those are going to either connect or have some kind of effect. There's been some excellent research, some of which we funded, into the ways in which, for example, wind energy can play a greater role than was previously imagined in maintaining and restoring the electricity system, for instance. But my colleague Simon is going to pick up a lot of these themes at the end of this session, and he's going to look at whole system and grid issues and research needs. So this is just something of a drum roll for that from Simon. I've referred to hydrogen briefly, as we're hearing more and more about the potential interaction between more large-scale renewable generation and the development of green hydrogen. And this is something that Juliet will be talking about in a bit more detail about our hydrogen ambition and innovation challenges just when I'm done here. And finally, on BECCS, our climate change plan update made clear that BECCS, bioenergy with carbon capture and storage deployment, can deliver the negative emissions which are going to be essential to hitting our emission reduction pathways. But while we know there's a huge amount we still need to learn across some of the economic and resource effect and environmental fronts, we're not as clear yet, I think, on the extent to which there are still technological and process innovation challenges in that area that further research and innovation will help us target and resolve. So that's something we'll be looking at very closely in much more detail over the coming year. Craig, that's me done. If you want to skip on to Juliet's slides.
Morning, everyone. So I'm Juliet Cramb-Low. I work in the policy team, the hydrogen policy team at the Scottish Government. I'm the head of hydrogen evidence and engagement. And before I talk about some of the hydrogen technology challenges that we see as a priority right now, I want to first touch on the wider policy context and the potential opportunity for hydrogen in Scotland as we see it at the moment. So last year we undertook a hydrogen assessment project, which assessed the potential roles that hydrogen could play in our economy and in our energy system in Scotland. And this led us to publish our hydrogen policy statement in December last year, which set out our high-level ambitions for hydrogen and the role that we think it could play in Scotland. In essence, we believe that there's a really significant opportunity for Scotland to produce large volumes of clean hydrogen, which could help us not only reduce our domestic emissions, but also allow us to develop a role as an exporter of hydrogen to other partner nations, particularly in Europe, and in turn to create and protect jobs in Scotland and provide an economic benefit to Scotland. The slides here set out at a very high level some of the key points from our policy statement. But in summary, we've set an ambition to have 5 gigawatts of installed production capacity by 2030 and at least 25 gigawatts by 2045. Now, those are really big targets. To put them in context, the 5 gigawatts by 2030 target is the same ambition that Germany has. So a much larger economy with a much larger industrial base. So really challenging ambition, lots of work needed to get there, lots of innovation and lots more academic research required. But we think that they are realistic and achievable targets based on our evidence gathering last year. We are supporting both blue and green hydrogen production. Like the UK government, we're pursuing a twin track approach. We think both will have a role in our reducing our domestic emissions. Particularly, we think that there's a potential role for hydrogen to play in decarbonising industry, transport, and potentially heat, as my colleague Craig has already mentioned. And our analysis tells us that we can produce enough hydrogen to not only meet those domestic needs, but also to support that export market to Europe. And that would be achieved in the main by unlocking the vast offshore wind potential that Neil has just mentioned, and resulting hopefully in allowing Scotland to produce large-scale green hydrogen that is competitively priced within a growing European market. The image on this slide sets out what that could look like, how a potential large-scale electrolysis plant aligned with renewable energy supply could service both a domestic market and an international export market. But this is, of course, a nascent sector. So to realise these ambitions, there's still a great deal of research and innovation required across the full value chain to increase the efficiency of production, transportation and storage of hydrogen, and to optimise and understand its role in decarbonising heat, industry and transport. And there's a lot of work underway globally at the moment to look at some of these challenges. So on the next slide, I haven't covered all of the innovation and research requirements because that would take the full hour. So what I've just tried to do is highlight a few of these that are key priorities for us, key research and innovation priorities to help us achieve the hydrogen ambitions that are set out in the policy statement. So the first of these, and arguably one of the most important to reach our 2030 and 2045 ambitions, is the need to be able to produce cost-effective green hydrogen. And to do this, innovation is required to reduce the cost, increase the efficiency, and optimise green hydrogen production via electrolyzers. In terms of innovation, this could include looking at the different operating temperatures, materials, looking at efficient feed water purification and the ability to use poor quality water. But it also critically includes the need to understand the optimal type of electrolyzer for different applications. So which would be best suited to large industrial use, which would be best suited to small renewable applications in rural communities, for example. There's also a need to explore the role of hydrogen as an energy store and its potential role in providing a flexibility or balancing function to the grid. Today, natural gas provides one of the largest energy storage mechanisms in the UK energy system, and it is responsible for providing critical flexibility for a wide range of energy system applications. However, as we reduce our reliance on fossil fuels and we transition to net zero, hydrogen potentially provides one of the most viable opportunities for large-scale sustainable energy storage, whether that is long-term storage to help meet seasonal peaks in electricity and heat demand, or whether that is medium-term storage to help manage the intermittency of output in renewable energy resources, be that wind generation, for example. But we know that there's a need for further research and innovation to understand the efficiencies and performance of hydrogen fuel cell batteries and the role that they can play as an energy store. In addition, there's a need to evaluate the use of hydrogen as a feedstock for green synthetic fuels. So synthetic fuels could be one answer to helping to decarbonise certain hard to decarbonise sectors. So for example, in aviation, in shipping, or potentially long distance haulage. So there are various, in aviation, for example, there are various global trials at the moment, including in Scotland, looking at small sized electric powered airplanes. However, scaling up to a full size airliner is often considered challenging or impractical because of the size and the weight of the required battery pack. Hybrid planes are also being looked at the moment. However, they're not carbon neutral and so wouldn't deliver the emissions reductions needed. So carbon neutral jet fuel is therefore a potential answer to helping to decarbonise this sector. However, we recognise that further research and techno-economic financial evaluation is required to fully explore and understand the opportunities and potential for hydrogen as a feedstock for green synthetic fuels. And then last but not least, I'll round these last two up into one, but it's the need to optimize storage and distribution technologies. So effectively, we need efficient, low cost, short and long term hydrogen storage and distribution technologies for domestically and for export. And innovation and research in these areas could include looking at the optimal storage solutions at local, regional and national level to assess which is best for which circumstance. It could include improving the processes and understanding infrastructure considerations for short-term chemical hydrogen storage, such as ammonia or LOHC, or component-specific innovation to increase the efficiency and reduce the cost of hydrogen distribution. Now, this is by no means a comprehensive list of the innovation and technology challenges required to drive and develop the global hydrogen economy and the hydrogen economy in Scotland. And my colleagues have already touched on hydrogen for heat and some of the other end uses for hydrogen where there are also significant innovation requirements. But these are just a few that I wanted to highlight today as key areas of interest for us to help us achieve our hydrogen ambitions. And I'll stop there and I'll pass back to, I think we're over to Stuart next.
Hi there. I am Stuart Watson. I lead a small team looking at decarbonising industry in Scotland. So I've just got a couple of slides which won't go into technological detail in any way. It's more about the approach of how we're tackling the policy area and how we're tackling the challenge, building a framework of policy, and also a little bit on the drivers, in particular the climate change drivers. Just quickly, what our policy area is looking at is manufacturing industries. So industries that use energy consumers to make things, rather than industries that are involved in the energy supply chain. So that's the angle that we are dealing with, and it's Scottish industry is responsible for around about 30% of Scottish greenhouse gas emissions, with energy intensive industries around about half of that. The energy intensive industries are sort of the core of Scotland's manufacturing base, and they tend to cover oil and gas refining, cement, pulp and paper, food and drink sector, which is big in Scotland, steel, chemicals, glass and ceramics. So they're broadly the energy intensive manufacturers that we're dealing with. We particularly focus on clusters where there's significant numbers of energy intensive industries co-located, in particular the Grangemouth cluster, the largest in Scotland. Oh, my slide has disappeared. Oh, no, it's back again. Okay, primarily our aim is to create the conditions for decarbonising industrial manufacturing. And I've got 6 themes there on the slide. Themes of activity, looking to drive efficiencies, always more makes more sense to decarbonise a system that's already efficient. Looking at incentivising demand for low carbon products, learning from and influencing others, and that includes broadly a lot of our work, which is working with UK government, who still possess a lot of the levers to decarbonise manufacturing. Infrastructure to enable decarbonisation. Strong crossover there with what Juliet was talking about in terms of hydrogen economy. Transition planning, so this is thinking about how industry can decarbonise and what government and industry will do together to make transition happen. And that links to the top one there, which is fostering partnership with Scottish energy intensive industries. So much of the investment needed to decarbonise industry will come from private sources from around the world. So we need to work together with them. So those are broadly our themes. Craig, if you just press the button for the, around the outside there are kind of the policy areas, let's say. I won't cover all of those, but broadly, these are we have to keep an eye on pretty much all of these. You'll see there's things like material and energy efficiency, supply chains. How do we deal with regulating energy or emissions? A lot of that is still reserved at UK level, so we work with UK government on that. And moving over the top left, things like engaging with industry and looking at skills and capacity within industry to do things like identify where the opportunities are and how to actually deploy those opportunities. Craig, if you press the button, just there's a few square boxes popped up there. Now these are actually more like the areas that we're working on. There's some acronyms there we'll explain in the next slide. But for example, the hydrogen economy and CCUS, which is carbon capture, utilization and storage, we know from research, from various sources, both Scottish produced, UK produced and international, that in order to get to net zero carbon industry, the hydrogen economy and capturing carbon and storing it is going to play a very large role in doing so. And that links very closely with how we enable infrastructure investment and deployment to allow industries to switch fuels because primarily industry still uses a lot of fossil fuel to produce the heat required to manufacture or process their products. Okay, next slide. So this is a slide that shows broadly, if you look on the left-hand side, the aim. What are we trying to do? Well, we're trying to improve the conditions for energy-intensive industrial manufacturers to invest in reducing process emissions. UK Committee on Climate Change have said for the past 2 or 3 years that governments, and that includes Scottish government as well as UK government, should be looking to make a more coherent framework of policy. And really, we're in the action of doing that now. Our climate change plan that was updated in December 2020 has several policies or policy proposals which add up to a framework. I think we're still working on making that fuller and more coherent. And you'll see the primary driver there is for all this work is to reduce emissions according to those targets. I will just end on a couple of points. I won't cover all of these drivers and secondary drivers, but you can see how the aim links down to sort of our individual policies. I'll just highlight one in particular, maybe two actually. The Scottish Industrial Energy Transformation Fund is a policy which is about co-investing with industry. So we're working closely with agencies and manufacturing industries to aim to draw in match funding for investing in more efficient industrial processes. And the final thing I'll mention is a proposal for a Scottish Industrial Decarbonisation Partnership. This is about structuring engagement with manufacturing industries in order to work with them on transition planning, so that for the long term, the proposals to decarbonise industry more deeply can happen within a structured and sequenced set of events. I'll end there. Okay. Over to Simon.
Hello. Hi, everyone. Thanks, Craig. Hi, my name's Simon Gill. I'm head of whole system and technical policy at Scottish Government. And I work with Neil Rafferty on the electricity networks particularly, but also have a focus on aspects of the net zero transition, which are cutting across the whole system. So I've got 2 slides, one to talk briefly about grid, and then one to talk about the wider energy system. So on grid, I think grid and networks, what that really means to me is whole electricity system. And this is an area which Scottish Government is really strongly focused on. We've done a great job in Scotland, I think, of decarbonising electricity generation over the last decade, and we need to continue doing that. Scotland is going to go first, I think, in terms of reaching a net zero electricity system, and the climate change plan update that we put out before Christmas shows a pathway which has us reaching net zero electricity before the end of this decade. And that raises a number of challenges for how we develop the electricity system. It's obviously not an area where Scottish Government has devolved responsibility, but it's one where we work very closely with the sector, with the companies who own and operate the networks, with Ofgem and with UK Government on how the system overall needs to develop. So I think there's sort of two groups of challenges that it would be really useful for the ETP to bring forward projects to look at. So one is what I'd call sort of the energy issues, the energy balancing issues on the electricity system, and the other set is operability and security of supply issues. So on the energy issues, so this is about balancing supply and demand, matching those two up, ensuring that the networks can transfer energy from where the electricity is generated to where it's needed. And I think in this sphere, a lot of technologies are really well developed and very mature. What isn't mature is the integration of those technologies in the real world context to deliver this in the future. So what we need to do is take the technologies that exist, like the ability to monitor, control and communicate across a system, and interact, and how that interacts with the way people behave. For example, the way domestic consumers behave when they use electrified heat or EV charging, for example, the way businesses and industry can respond to signals. And we need to match all those things together, the technology, the interfaces and the behavior of the users. And that is an area where I think there's a real challenge. There's been loads of work done academically and theoretically, and some really good demonstrations and trials on aspects of this. But I think there's a huge challenge which we need to develop solutions to this decade, which look at practical applications of that. So I think that's kind of like the big thing that I would focus on in that area. On the operability and security of supply issues, this is another area, and it's an area where we, I think, need technologies to come forward. In the climate change plan update and some of our other documents, we highlight the focus that Scottish Government thinks needs to be taken on developing sustainable security of supply. So I think it's in the broader consciousness of society, politicians, policymakers, industry, that we need to decarbonise the megawatt hours of electricity that are generated, and that's what we've done a great job on. But we also need to make sure that we have zero carbon ways of providing stability to the electricity system, providing black start, restoring the system following a power cut, ensuring that reactive power, inertia, technical services that the current electricity system needs can come from zero carbon sources as well, and that we're not kind of having to fall back on fossil fuel generation at some point just because of the need to provide some of these additional non-energy services. So Neil mentioned earlier we've had some success in this area, and I think one of the big ones is that we part funded a project with Scottish Power to demonstrate the first ever black start from a commercial wind farm at Decarbonisation. And I think there's great opportunity to sort of move forward from that and think about how technologies like virtual synchronous machine and the control system within renewable generators can support sustainable security of supply and operability. There's the need to think about other technologies, like the role of energy storage in doing that, like the role of things like synchronous compensators, like other new technologies, and how they can be brought forward and delivered within Scotland, and how they can fit within our context. So there's a whole bunch of stuff there that I think is really interesting, and it'd be great to see some projects come forward on that sphere. I'm going to skip on because I know we're kind of reasonably short on time. So Craig, can you go to the last slide, please? So the previous slide I was talking about the whole electricity system. And I think it's also really important that we think about the whole energy system, and we think about that really quite broadly. And there's a range of challenges here that I think that we in Scottish Government, the UK Government and the sector as a whole really need to grapple with. There is a very strongly developing narrative around the need to do a systems approach to the energy system. And I would like some of these projects to be able to pick up on that narrative and drive it forward. So the challenges, I think, go from, on one side, a kind of relatively what you might almost call soft focus on how we communicate the challenge and importance of a systems approach and help politicians, policymakers and others to sort of visualize the energy system. So we've got that kind of soft approach right through to what I think will be very useful, which is developing a kind of really hard-nosed systems engineering approach to developing the energy system as well. And so I think there's opportunities to bring those forward. So a couple of things on this. On the left-hand side, I've given you an example. This is the picture that I have in my head of today's energy system as a kind of a Greek temple with 3 pillars. You've got a petroleum pillar leading through from the oil sector down through refining and meeting transport demand. You've got an electricity pillar coming down from electricity generation through the networks to meet demand for electricity. And you've got a natural gas system from gas production or import through the gas networks to meet heat demand. And there's a little bit of interaction between those pillars, and in particular, the interaction between natural gas and electricity through gas-fired power stations, and the fact that electricity actually meets a substantial part of heat demand even today. So there's a bit there, but actually those 3 pillars are reasonably independent apart from those linkages. So that's a picture that's in my head of today. But what is the equivalent picture in 10, 20 and 30 years' time? I think being able to articulate a picture like that will be really important. And whilst that might not be the full focus of a PhD work, I think there's value in thinking about how a systems approach is communicated and can actually direct change. On the sort of more hard-nosed systems engineering approach, I think systems engineering has got a lot to offer in terms of developing the energy system. As a process, it's been developed in other sectors. I think notably the American military used it and developed it in the 20th century. The aircraft industry is a sector which is, I think, archetypical in how it uses a systems approach. And if you were to take an example like, I don't know, say an aircraft company like Boeing, they're fully in charge of building an aeroplane. They're in charge of making sure all the different subsystems within an aeroplane interact appropriately and safely, and they have to get everything right in order to make the aeroplane work as a whole. There's not actually an equivalent to that in the energy system. We don't have an equivalent to Boeing in charge of everything. But we do need to think a lot more strongly about things like the interfaces between different subsystems within the energy system, and how we design those. And I think that's really important. And I think I'd be really keen to see anyone looking at that aspect of the application of systems engineering to the energy system. And I think related to that is a question about risks, for example, and I think how we quantify and use risk in decisions about the energy system is really important and needs quite a lot of development at the moment. So just as a kind of example of the sort of thing that I mean, if we move to a very electrified energy system in the future based primarily on renewable generation with lots of storage, then that reduces the amount of energy we need to import from abroad, and then therefore helps manage the risks associated with maybe geopolitical issues and challenges to the international trade in energy. But it puts a bigger risk on associated with faults on the electricity system and what happens if you have a substantial blackout, because much more of the economy and society relies specifically on electricity. So I think thinking about those risk elements is really important. So I think there's a lot more I could say there, and we could bring in all the aspects that the other speakers have talked about, linking electricity generation and industrial demand and hydrogen and things like that. But I'll stop there, I think, and I'll be happy to answer any questions or follow up by email afterwards. Thanks, Craig.
Well, thanks, Simon. So hopefully everyone found that was and thanks to all the other speakers, hopefully everyone found that a useful whistle-stop tour of Scottish Government energy policy. We are over time, I'm conscious of that, but happy to take any questions, short questions in the chat, or indeed happy to figure out a way that we can follow up with you questions wise after the session as well.
Hi Craig, yes, absolutely. You probably can read the questions as well as I can in the chat. There's been quite a lot of discussion around the role of Ofgem in the energy system and how almost, I think, to circumvent it, I think. There is one question I have actually, is that a lot of these issues are, you could say, policy related to do with the system, and remembering that we always need to bring in an industrial partner. It's maybe we can, ETP and the Scottish Government can maybe help whichever supervisor would like to do a project in these areas, see we can actually find somebody if they don't have that already, because that could be an issue in this particular case if there's not an obvious impact on one specific industry or industrial partner. I have a question here which says about geothermal energy, just changing a bit. Anything on geothermal energy, Craig?
Yeah, but I'm conscious that we've not explicitly referenced geothermal energy in any of the slides. That's not to dismiss its importance or the role that it could play. I suppose within the heat and buildings challenge specifically, we've outlined a significant role for heat networks, and our Heat Network Scotland bill has just in the last couple of days become law within Scotland, setting statutory targets for the deployment of heat networks across Scotland in the next 10 years, and the role that geothermal could play in supplying those heat networks is certainly something of interest to us. So yeah, I'd be happy to see projects coming forward on that particular theme.
Okay, thanks. And Simon has his hand up, I believe. Simon, is that on purpose?
Yeah. I was just going to comment on your question, Stephen, Mark, about that issue of technology, and I think I was thinking that in terms of the systems approach, that there's lots of policy questions, but I think I'd be interested to see how you could bring in industrial support for that, and I think it's important to do so, whether it's maybe like industry kind of helping map out their space in this or what, but I am conscious that's a potential challenge there. Yeah.
I suppose just to comment on that as well, conscious that there's not a clear barrier between policy and technology challenges. There's obviously a requirement that we attract match funding from industry into these projects. So having a commercial driver behind them is important. But quite often that commercial driver can be overcoming a policy barrier. So helping to achieve some of our ambitions and helping to inform Scottish Government policy may be of commercial interest to companies. If there's anything specifically that you're thinking about that causes concern about attracting that kind of match funding, I suppose, as Stephen Mark said at the outset, come and speak to us. We have good networks of contacts across industry as well as policy and between Scottish Government and ETP. I think that we can, as Stephen Mark said at the beginning, nurture projects through this process.
Okay, well, actually, I don't think there are any. There's a bit of chat about, and apologies to Susan, yes, I shouldn't have used the word circumvent, transition or modernise Ofgem, she says. There are no actually any specific questions, so I think we'll leave it there. I think it's been absolutely fascinating. I think not just within the context of the ETP PhDs, but of the ongoing conversation between policy and the Scottish Government and academia and research on the other side. So hopefully that's a conversation that we can keep going. But I would like to very much thank you, Craig, and your colleagues for, if you could please send me a copy of your slides so that we can put them up on the website, that would be great. Apart from that, all I can say is thank you and goodbye.
Thank you, everyone. Thanks.